You know what? Some people would say that API design is a very simple topic, yeah? And to a certain degree, that may surprise you, I would agree, yeah? Because basically, when you are designing the API and you consider only the very, very limited scope of just transferring the data from system A to system B, then of course, it is very simple, yeah? We know how to do that. We take the data out of the storage, we serialize it, we return it, and yeah, boom, you have an endpoint, you have an API, yeah? That's it. But of course, the whole problem starts when you consider the wider scope, the wider perspective. Because if you, for example, have your own application, yeah, that's cool. You are the only provider and the only consumer of your application. Then it's good, yeah, because you can always talk to yourself. I need more data, I will give myself more data, yeah? Like you control everything with regard to how your API is operating. Maybe you are at some point in time, let's say, working in a bigger company when you have many teams, some of them responsible for the API, some of them responsible for the front ends or the other systems that are consuming that API. And in this case, of course, you can still ask them, yeah? If you're working in the office, you can just go to them, let's say, tell them, you know what, I need another endpoint, or I need more data, or less data, or different data, yeah? If you maybe you're working remotely, like is possible and popular nowadays, you can still, let's say, ask them on Slack, on Discord, or whatever other, let's say, communication method you are using, yeah? But the whole problem, and especially given that we are on SyliusCon, yeah, with the platform, that whenever you are releasing that API to the public, you don't control that environment anymore, yeah? You can't really, let's say, influence how your consumers are using that API, which means effectively that whatever you will publish will be just there. Yeah, it's not your API anymore. It is our API, like our as in your and your clients. Yeah. So that's why exactly I would like us to say to follow and to have in the back of our minds deeply the quote from the Hiram Wright, one of the Google engineers, who stated one time that with a sufficient number of users of an API, it doesn't matter what you promise in the contract. All observable behavior of your system will be dependent by somebody. And in this context, this quote the scope of this quote is much wider, yeah, because even if you have the interface in your code, even if you have the class or like a method signature and so on, those are also APIs. Just like Sylius API is the API, but also Windows API is an API, yeah. Linux kernel API is an API, yeah. But in this scope of this presentation, we're talking purely about the network APIs, about the web APIs, like we are typically used to, yeah. So whatever you will publish, it is already there, and you have no idea how other people, let's say, are using your API. Yeah, so beware basically of designing something in a wrong way. So basically, the question is, what is even a good API? What can we call a good API? The question is, as always, as all consultants say, it depends. Yeah, because it depends, let's say, on what are you trying to achieve. So I don't think, let's say, that, and I wouldn't really argue, let's say, for a reason of basically making that there is something as a good API. Yeah, maybe it is good in some context, but in general, we can follow certain rules and certain like advice to be able to design the API in a way that simply leaves us with the ability to evolve the API and change it over time while still considering that it is not our, it is someone else's. Yeah, so someone else is also the part of it. Because if you change something in your API, and if it is public, you can't influence how other people, let's say, are implementing it. Yeah. So in this presentation, basically, what I would like to do with you is to take you on a journey of basically what we as developers, as providers of the API are doing, but also what are the clients of our APIs are doing as well. Because we are also quite often consuming APIs, so even though, let's say, we as like IT people, we are mostly like developing, but we are also quite often consuming them, yeah? So as you will see, both the producers and consumers of APIs go usually to the very, very similar role of very, very similar set of steps that outline, let's say, whatever is happening with this. So, of course, the first step is that clients are going to learn whatever we design, yeah? Because at the beginning of development, there is an idea of what do we actually want to implement. Yeah, we usually describe it in some form, let's say, of the API description. Yeah, and what the clients need to do, they need to learn it. So how can we do that better? So first of all, we want to make it easy because we want to avoid any of the potential client misinterpretation. Yeah, like first of all, of course, we want to make it easy because we want our API to be approachable by people. We want them to be able to easily learn that stuff. But even more, we want to actually avoid them misusing it. Yeah, imagine, for example, that you have an endpoint, let's say, which provides us a certain operation, like an example of operation that can be misused in any way, and clients can use that to like indirectly, let's say, arrive, let's say, at the effect that they want to achieve. Yeah. If you will then fix that endpoint, yeah, to not make it possible, it is actually a BC break. You can't do this. Yeah. So that's why we want, let's say, to describe the API as well as we can, because we don't want, let's say, to allow them, let's say, to misinterpret it, yeah, and also misuse it. Yeah. So that's why, since a few years, we have a very nice solution, that at least a part of the solution, OpenAPI, which can be used, let's say, to describe it. Yeah. And apart, let's say, from the typical description, yeah, like whatever your API is doing, let's say, you will put the best description of what you have. It is usually also, let's say, good to talk about the so-called API description architecture. I know that typically you wouldn't really think about architecture in terms, let's say, of the API description, but still, when you are creating, say, the API from scratch, you're having, I don't know, like maybe 10, 20, 50 endpoints, yeah, it is still will fit kind of in a single OpenAPI file, but then it will be, let's say, much harder, let's say, as it goes, to describe it properly and also make it happen, yeah? And let me tell you, because, I mean, I have a pretty beefy PC, let's say, at home, but still, if you will have that in a single file, you won't be able to work with it because, let's say, of how much resources it will consume in a reasonable IDE, like for example, PHP Storm. Yeah, so the architecture that I am using pretty often in various applications is that I divide it, let's say, to a certain set of files. And the first file is a so-called routing file, where we define only the endpoints, like the URIs, let's say, that will be exposed, and we immediately reference them from the other file. Which means that the routing file, whenever we'll have, I don't know, like 10, 20, maybe 50, but maybe like even 100, 200, 500, 1,000 endpoints, it will be a pretty small file. So you won't have any problems with actually describing, say, properly how that API should be described. But then, for example, you want to reference those, yeah? So see that we have the two resources, like account resource and book resource, yeah? And we proxy them to the account JSON and book JSON. So then what we want to do is that in each resource file, we are describing only this resource. Yeah? So those /list and /view aren't endpoints. They are just pointers, let's say, that we're using in the $refs, let's say, in our file. And then you have a pretty small file which describes only a single resource or like a single scope of our API. See, we have, let's say, all those, you know, like a collection and single element endpoints, but also we have request bodies, responses, and schemas, and everything, let's say, that is concerned with this particular resource, which already kind of splits your description into many small files that are much easier to use. We then also have the so-called shared file. And the shared file is, as the name implies, to define all potential reusable parameters, request bodies, responses, schemas, and so on. Which means, for example, that if your API wants to be consistent, then you, for example, will use the one, for example, HTTP created, which will be always, for example, an empty 201 with a location header. Yeah. So whatever you are doing, yeah, you will be always doing that reference, unless you maybe have, let's say, like 1 or 2 endpoints that will deviate from this, yeah? But whatever your API will do at any point in time, if you want to change it API-wide, you will need to only change, let's say, it here, yeah? And why do we want to do that? Because we also want to uphold certain contract conventions, which will enable us to not only describe, let's say, the API, but also, say, make it reusable and also make it much more understandable if the clients of our API will see the description and they will see that we are referring to the same data structures as in many places, yeah? Which means basically that, consider this example. If you, for example, have the endpoint, yeah? Let's consider the first one. The story is, as it usually is, you are required to, I don't know, provide the endpoint for the user details. Yeah, so okay, you will return the ID, name, maybe some other details, but that's effectively it. Then someone else comes to you and tells you, you know what? I would like to have the company name because I don't know. I'm on the front end. I want to also show a model, let's say, with the company name that you are working for. Yeah. But we, of course, know, let's say, how it goes. Yeah. Then it becomes the company employee count, company tax, company articles, company whatever. Yeah. And that will be even nesting, even more nesting. Yeah. So we can't really, let's say, do much about it. Yeah. What we want to do is that we want always to consider the meaning of the data. So is that company ID only a scalar? Probably not. Probably that means, let's say, that this user is connected to a company. So we have two resources linked to each other. So we always want to give those linked resources their proper space. Because if we describe it properly in both the payload and response structure, yeah, we can evolve that, let's say, however we want. Yeah, both the company ID name, tags, and so on. But if those tags have articles, if those articles have authors, and so on and so forth, you will be able, let's say, to easily evolve the description. And you can also use that in other endpoints, the same structure. Because, for example, if you use like an ID name, like a minimal description, you can have it as a reusable schema that everyone will understand in your API description. That it's about a typical smallest representation of each of the resources that you have. Yeah, and also the same with the shared JSON with all those identifiers. You typically in the API we use like one or maybe two, let's say, identification schemes. So that also makes sense as to describe it like here. Yeah, we have the identifier schema, which is the string consisting of digits, and you have the reference, which is an object that is referencing the identifier, yeah, which makes sense in a lot of places that you aren't writing that the identifier is like an integer or a string with digits and so on, because those are two different types. Yeah, you want to rely on the identifier because everyone will know that whenever you're referencing, let's say, the resource, you are referencing an actual identifier. Yeah, so we have those things, yeah. But what the other thing that we can consider, say, on the API description side, kinda, is providing the client libraries, because the clients will need to learn it. But at some point, they will maybe have a clever developers on their own side, yeah, who will, instead of using our code, our examples from the documentation, they will try to actually use, let's say, their own code, yeah, like do it, I don't know, with Gazelle, with curl, with whatever, and using the client libraries. Of course, this will require quite a lot of effort from us to support those libraries, to actually provide them, maintain them, yeah, provide the latest version, and so on. But in general, if we do it, let's say, properly, we will be able to push away the support boundaries of our whole application. Because if the developers of those client libraries will, at some point, let's say, tell us, you know what, something is not working, yeah, like we are not able to log in, we are not able to fetch the resources, we're not able to call those requests, yeah, you can tell them, look, show us how would you reproduce it using our SDK. Oh, we are not using your SDK. So could you please compare it? Because we know we have tested, yeah, that it works. Yeah, so we kind of, instead of receiving like hundreds or thousands of tickets that your API isn't working as it should, by providing the SDK, you automatically push away the boundary of the support. Yeah, including, for example, like public repositories. Yeah, where someone can file issues. Yeah, and other people can tell them, you know what, use the SDK, let's say, in this way. Yeah, which helps you, let's say, develop even further, even faster. So this is basically the first step. But the second step is that after we have designed and clients have learned, the clients will then quite often will need to verify, because they will kind of expect, let's say, the failures of our systems. Yeah, like no system is bug-free. Yeah, but it's in our interest to provide as much quality and as much quality assurance, let's say, as we can before clients will do that. So basically, the clients will verify what we want to test, which means, in another way, we want to test it as much as we can so that client won't need to verify, let's say in live in the production systems. Yeah. So how can you do that? And one of the things that really helps me, and it's one of my favorite things about working with APIs, are the Gherkin scenarios specifically designed for APIs. Maybe you have worked, let's say, with Gherkin and Behat, which is the PHP library, let's say, which kind of handles, let's say, Gherkin in PHP language. Yeah, but designed for APIs means that those matchers, those structures of given when thens, are specifically designed, let's say, for the way the APIs work. Yeah. So let's consider one example. Given scenario as an authenticated user, I want to create an invoice. Given there are following users, and I am authenticated as a user, when I send a post request to path invoices with JSON payload, which is irrelevant right now, the response code should be 201 with the location header and some value, and the response body should be empty, and we verify that it happened by sending a GET request to the location header. Yeah? Notice all those blue fragments. Those are parameters, which means that you can, after some time, if you invest in writing, let's say, the solutions like this on your own end, you will be able to assemble the scenarios like they were Lego bricks. Yeah, like there's no more development needed. And another benefit is that everyone will be able to understand how the API works, because they will be basically needed to only understand maybe what post and get means. Yeah, like if you tell them that both the testers, the front-end developers, the business analysts, yeah, the managers, and so on, if you teach them that post means create, yeah, and patch means update, and so on, they will be able to read it as if that was English. Yeah, I was able to successfully deploy it in very many projects to say that basically this was like making a Behat scenario for the API that we wanted to develop was literally the very basic step that we always did, because everyone was trained to say how to read this stuff. Yeah, like even if they ignored certain things like what is 201 or what is even this thing. Yeah, like they understood what it was about. Yeah, it wasn't really that hard. And then we can, of course, implement those. So as you see, when I send a post request to path something, those are the parameters. Yeah, we can then send request. And the same with assertions. Yeah, like assert saying that the code that was here in the matcher, yeah, matches, let's say, the response code. Yeah, so definitely, if you haven't worked with Behat, if you haven't worked with BDD or behavioral scenarios, please do. That will be definitely, say, good, let's say, for you and your career and your skills in general. So you have seen that right now we are skipping, let's say, the send request. Why? Because by using, let's say, those Gherkin scenarios in that way, we can actually achieve another benefit of having the so-called verifiable consistencies. Because what we want to do is that you have maybe remember that 10 minutes ago, maybe we have defined, let's say, the open API spec. Yeah, like we have described it, let's say, with the best ability that we could. So right now, we will not only, say, ship that to clients, show them that as the documentation, but we will actually use those schemas to automatically verify that if our tests pass, they also verify everything about the API schema. Notice this. We have the send request method, yeah, and we are using here the League OpenAPI PSR7 validator, yeah, that we, of course, what we need to do is a green line, yeah. Response is a kernel handle. But before sending, let's say, the request, we'll actually verify that that request matches what we have defined, let's say, in the API schema. And after processing the response, yeah, if there wasn't an exception, we will validate as well the response. So that means that we have three things. We have our code of our application, we have the API schema, so the API description in general, and we also have the Behat scenarios, yeah, the behavioral scenarios, which means that if even one of those changes at some point, two others are verifying, let's say, that it works like it should, yeah? Which means that if your test case is green, then it means that your API simply works, yeah? Especially if your Behat scenarios are written in a matter of end-to-end tests with the real database, with the real infrastructure, and so on. And I have found that this to be really, really a good quality measure for actually making that work. So what do we want to do next? So we have defined the API, the description. Clients have learned them. Then we have tested them as much as we can, potentially, and also implemented the API. So now the fun part begins, because now our API is live, and someone starts to actually make requests to it. So the client will interact with what we have implemented. Yeah? And what we want to achieve in this particular place is that we want to make the observable behavior, remember Hiram's law, we want to make the observable behavior, let's say, as much in line, let's say, with what the client expects, and also communicate our expectation very, very clearly. Because when they will start sending the request to the API, it means that they will, at some point, encounter errors. Yeah, either like errors, let's say, in the payload that they are sending, in the missing headers, in the whatever kind of errors, let's say, that they will be able to come up with. Yeah, and what we want to do is that we want to communicate as clearly as possible what was their their problem, because otherwise it becomes our problem that they will ask a question like, why doesn't it even work? Yeah, there's a lot of APIs which return errors in the form just error, something happened, error, I know, failure in saving something. Yeah, like we don't want that. We want to inform the client as well as we can, let's say, about all the stuff that is happening. And of course, at least a big part of it is the request validation, when we want to enforce whatever, let's say, was defined there in the API schema, while still informing the API clients about everything, let's say, that is happening underneath. Yeah, and one of the examples that I am using, say, in my own projects are, for example, this kind of DSL, so like a domain-specific language for validating stuff. Yes, this is one of the libraries, let's say, that isn't open source, but I have developed for many of my clients. Yeah, that here we are stating that we want to verify the request payload with the name string, title, which is nullable, company, which is a reference to another, let's say, entity. Then we have the tags, which are a collection. We have the optional ID and required name, which are those types. Yeah, you can do it with any other, let's say, other validator. For example, like this. Yeah, because there are many validators in the market that you can, for example, define your validation as some kind of DTO, when all the rules will be inferred based on the class. But I have found, let's say, this DSL, let's say, approach, let's say, to be really good, especially when you consider that I can have, let's say, a lot of so-called inverted rules, yeah, like the conditional approval of certain fields based on the presence of other fields, rules like either, or, XOR, and so on, which aren't really able to be defined, let's say, this way, yeah, because how will you define here, let's say, that name is available only if the title was also passed, yeah? Okay, you can do that with attributes and so on, but in this approach, it's simply, let's say, like natural, like right in the DSL, yeah. But whatever you do, you want, let's say, to have that implementation. Why do you want to have it? Because, of course, you want to respond with errors in a way that is understandable for the clients. And for many years, in various APIs, I have seen like different companies, different teams of people were coming up with their own schemas of how they are returning errors. Yeah. Fortunately, we don't need to do that anymore, because we have the RFC 7807, which is called Problem API, which is right now the standardized RFC on basically like how should you reply, let's say, with errors. Yeah. Which basically looks like this. You have the typical 400 with the media type application problems.json, yeah, which indicates that you're compliant, let's say, with the RFC 7807. And then you have two fields which are mandatory: the type and title. The type is the URL to actually the human readable page on which the user and the client of the API can actually learn more about that type of error, which automatically suggests that you can have your own developer portal, which of course you do have, with not only the documentation, but also explanation why that error happens and what that error happens for. And my validator, for example, is able to come up with, let's say, the violations, yeah, because the type and title are only the mandatory fields. So the rest is actually up to us. And we can define many different types of errors, describing under those URLs what are they for, but at least ones that I frequently use is the so-called payload violations, yeah? Which means that in these violations, let's assume that in the past example, all of those fields were invalid. So the name was meant to be string, but was not a string. The company was a reference, so the ID actually doesn't exist. And the tags, for the first element had the error in the ID field. The second one had the error in the name field. So notice basically like everything else that potentially would be in that payload was stripped out, and the client will exactly know which actual piece of the data that they sent is actually invalid and why. So this is like a mirror of the payload that the client sends to the API, and it replaced exactly in the same structure, which means that even if the client wanted to present the error to their client, let's say, in a certain way, they can do that because this is actually parsable. You can actually say which part does it actually apply to. Yeah? So this is the other kind of error, for example, like generic message, yeah, when you, for example, just need, let's say, to return some kind of messages, like a typical messages that aren't connectable to certain part of the payload, yeah. But you can do it as much as you want, yeah. It's just like RFC 727 is very extensible, let's say, and you can use it. So basically, right now, our whole API approach was like three-dimensional. Yeah, we didn't consider time in it. So now we actually will. Because when we have described the API, clients have learned them. When we have validated, we have tested, and then when the client starts interacting with, of course, the one inevitable thing that will happen is that we will need to deal with the change. So we will need to maintain whatever we have developed because the clients are relying on it. Yeah? So right now, all of the things that we are discussing so far will allow us to evolve our contract, will allow us to evolve the whole API approach, let's say, and also make us able to not only improve the API, but also keep it in the contract. Yeah, like to not catch the client by surprise, let's say, with anything that we would like to do. So what would we like to do? First of all, we would like to keep the backward compatibility. Yeah, because of course, as I said, we don't have any bugs in the API. If you have shipped a bug in your public API, it's not a bug, it's a feature. Yeah, you can take it back because you don't know if someone is relying on it. Maybe if you have shipped something to production and 5 minutes away you take it back, maybe no one was actually able to make the change in the 5 minutes that it was on the production. Yeah, but let's say that it was a week or a month or something. No. If you have discovered the bug like a month later, it's a feature. Someone is probably relying on it, so you can't really solve it because solving it is actually a BC break. Yeah, you can do that. So what you want to do is to, of course, introduce certain kind of versioning, yeah. And notice how initially, while describing the API, we have described it, let's say, as in terms of resources, yeah. So we want to describe, let's say, the resources, and the resources, we have many operations of them based on the media type that they expose, yeah. So in this case, we have something called RFC 6838. Which defines, let's say, for us the way to create our own media types. Yeah. So of course, it is not illegal to come up with your own, but this RFC in section 3.2 comes up with a structure of application/VND, and application after VND, so vendor, is up to us. So imagine we are here on SyliusCon. Yeah, it can be something like, for example, application VND Sylius minimal v1 plus JSON. If you want to do it like plus PDF, plus CSV, plus something else, you're free to do so. If you want to create different variants like basic, extended, for client, for user, or for whatever, yeah, or like even operations like merge, clone, or something, this is exactly what this should happen, yeah. And I don't know if you did that, but media types and headers in general can also have parameters. So you don't really need to even tag that versioning here. You can make it a parameter of this, which makes it either like application VND Sylius extended plus JSON version 1. Yeah, so you don't even need to be a part of that string. Yeah, so how many representations of the resource you need? That's the answer. How many operations do you need? That's exactly the answer, yeah? So you want to define, let's say, as much, let's say, on the resource level, and to fully utilize the HTTP protocol, which provides you, let's say, with quite a lot of stuff that a lot of people aren't really aware of, and I'm kind of doing the humble job of that's just uncovering, let's say, how much things you can do with the protocol that exists for the last 30, basically, years, yeah? So another, let's say, interesting thing, let's say, that we really need to take care about is that at some point, let's assume that, for example, you have a media type that you have already got to V5. Maybe at some point you want to phase out. Maybe at some point you want to remove it. Yeah. So what do? You just remove the code and return 404? Maybe not a good solution. Yeah. Because again, we don't want to catch our client by surprise. Yeah. You can just send them an email. Yeah. And you know we'll switch this and this and this endpoint somewhere in the future. And potentially there's a problem if that email will get lost somewhere. Say we'll have a problem. Yeah. So again, everything that we want to solve in terms of APIs is that we want to make it a part of the contract. Yeah. So of course, removing everything is a BC break, but it is a BC break only if you actually don't communicate it. So in this case, we have another solution, which in the RFC 8594, we have something called sunset header. And this is an automated way. I don't remember if that RFC is already production level, but it is so simple that it is like a simplest idea that you can use, because the sunset header basically acts as a date that you're returning as the header whenever you plan to phase something out. And you can actually communicate that in contract that you will do that. So basically, like in your documentation, you state sunset header will be no earlier no further than 3 months before we will actually plan to phase it out. And also, you also can have on the implementation side, you can have it implemented as just like a kill switch. Yeah, basically like if the current date, let's say, is bigger than some kind of hard-coded date, just return 404 or 406 or 415 or something like this, because at that point you will be able, say, to switch it off like programmatically. You don't even need to watch for that. And what you can also do is that assuming that your clients, let's say, will want, let's say, to bring it back because, I don't know, maybe they will pay you like millions of dollars, let's say, because they surely need that endpoint, yeah? You can just switch it, let's say, push it over. You don't need to make any code changes, yeah? You can just switch it off, and the client is expected at that moment to turn up their monitoring, so whenever any kind of endpoint that is used, let's say, return sunset header, okay, that's a warning in Nagios or in any other monitoring system, yeah? Like this endpoint is going away, and naturally we can escalate this, let's say, in the company to, as the client of that API, to be able, say, to react to it before it happens, yeah? So we have a good time because there's a few minutes left, yeah? So this is like a bit of extra content, basically, that I usually try, let's say, to push in the direction that you have maybe, during this whole talk, got the impression that what we are talking about is what is typically called REST APIs, yeah? So let me tell you that basically what we were talking about in this presentation, most like 99% HTTP protocol. And only HTTP protocol. There was nothing about REST. No resources, no media type, and so on. This is all HTTP. This is not REST. Yeah. So this is a pretty, let's say, like clickbaity title. Yeah. Like why nobody understands REST. But that's exactly, say, how I want to like catch everyone's attention. Yeah. And I want to make everyone aware that what we are talking about is the HTTP protocol, because what the REST is really about. Yeah. On one hand, it is about resources. Yeah. Because that's how the web works, right? Okay, that's a first assumption. So of course, let's say we can talk about that, yeah. But much more important thing is that REST is first of all about making your clients aware of what can they do that data, what can they do with that data. So imagine, just to give you an example, your favorite internet portal, yeah? I don't know, maybe let's say years ago you used some kind of portal, yeah? Maybe it's not that popular nowadays, yeah? But years ago, let me tell you, there was a lot of different portals when you had your email, when you had your news, your weather information, and so on. So notice what those websites did. When you enter that portal website, you could actually look for the email icon. You could use for the weather icon. And that's exactly what REST is about. That website was informing you what can you do with whatever was there on the screen. And what we want to do in API is that we want to inform the clients in the very same way. So we want to, if you, for example, have, I don't know, the get bank accounts with some kind of number, you want to inform your clients how can they, for example, withdraw the money if they have, let's say, some kind of balance, and you don't want to inform that they can withdraw money if they, for example, have a debt. With the invoice, you want to inform them how to check the status of the invoice or how to pay it, yeah? And that's exactly what the REST is in general about. So let me just state, I mean, it's not maybe a hill I'm willing to die on, but still, let's say, a statement nevertheless, is that we want to inform the clients about that, because that way, let's say, the clients will know what to do. And if you aren't informing your clients, let's say, what they can do with the data, yeah, seriously reconsider, let's say, whether you actually, let's say, want to use REST, because not every API needs to be RESTful. Not API needs to follow the REST paradigm, but still, REST is exactly about this. All of the other stuff is just technical fluff. Yeah. So what we want to do is, of course, treat the client developer experience just like we treat, let's say, the user experience, and that's exactly what it is all about. Yeah. Developers, just like users of our system, also want to have their own experience, yeah? So clients in general will love that you're thinking about them. Clients will love, let's say, that you are not only thinking, let's say, about how to produce APIs, but also how to consume them, yeah? And that's exactly, let's say, what in general should happen. So with design your APIs with purpose, the purpose basically is being, let's say, think about the client and all the other, let's say, use cases of your APIs have. And with that said, maybe there are some questions. Come on, you have some. I'm sure. Yeah, you have a question.
That was easy. Thank you. Does it work? Okay. Thank you for sharing, all these practices. I think they're really good for mature products, but when designing, let's say, a new product at MVP stage, what would you recommend are like the good practices to release an API fast, but still build a nice foundation for evolution in the future?
Yeah, so the good thing about everything, let's say, that you have seen in this presentation is that you can use none at all or everything, yeah? You can scale it, yeah? So for a product that is just starting, yeah, that you are designing the first endpoints, it's good to simply establish a certain kind of foundation. Yeah, like if you want to your API to follow certain standards, yeah, follow them right from the beginning. Yeah, like don't kind of like chip out on, like, for example, using media types and so on, because then on it will be much harder to break the contract. Yeah, remember basically that you can skip everything that is not crucial, that you will be able to take away, let's say, in the future, but you don't want to skip on anything that it will be very hard for you. Yeah, so if you are serious about, for example, versioning, use the right versioning from the start. If you are serious about the media types and sunset headers and so on, do it, yeah? But do you really need to design, for example, your payloads in an ideal way from the start? Possibly you can evolve that, yeah? You can always have the V2, V3, yeah? Do you need to, for example, test it ideally? Yeah, of course, you want to test it, let's say, for the amount that you simply make you sure, let's say, that it works, yeah? But as I said, yeah, everything here is optional. And let me tell you, most of the APIs I'm working with are none that way, yeah? That's what I'm talking about, yeah? It's like I'm trying to make it that way, yeah? But like literally none of them are, so.
Okay, thank you.
More questions?
Please, anyone, raise a hand. Don't be shy. In any case, Tomasz, you will be with us.
So in that case, let's say, I mean, a bit, let's say, of marketing, of course. If you have anything like this, let's say, in your own companies, let me know. I'm more than happy, let's say, to consult at your company and help you with this. And right now, the last slide. Thank you very much.